All right, welcome to the end of week 2. We're going to be talking about data types and vectors in R. I just want to thank Drs. Matt Espy and Anna Steele for the source material that went into this lecture. And let's just jump right in. So data types in R. Why do we need to care about them? Well, we need to care about them because our computers care about the type of data that you're trying to store on them. So just to get some vocabulary going, when I say data types, I'm talking about things like a numeric data type, which is also called double in R. These are things like the real numbers, anything with a decimal point or an implied decimal point. Integers, so whole numbers, characters, anything between quotes, basically. You can also represent numbers as characters. And then logical, which only takes on two values, true or false. So those are the four most common data types in R. There are a couple more less common types that we don't need to worry about for this course. Okay, so we're talking about these common data types because your computer cares about them when you're trying to store them in memory, and R works in memory. So every time we ask R to store a piece of data on our computer, R actually is pre-allocating the correct amount of storage or memory for that data before you save it. So in order to do that, it needs to know exactly how much space to pre-allocate, and how much space to pre-allocate depends on the type of data and the amount of data that you're trying to store. So if you're trying to store mixed type data together in the same vector or collection of data, R may need to coerce that data to the same type before it stores it in that pre-allocated memory space. And the reason that this coercion needs to happen has to do with the way that R is actually carrying out the manipulations of your data under the hood. I'm not going to go much into detail there. Just know that this system of pre-allocation, coercion, and memory storage is what is making R's programmatic manipulations of your data possible. And since that's what we're using R for, it's good to know why it's happening. But as essential as this coercion system is, it can definitely be confusing at first because after you have put your data through a function, you may see a logical vector of trues and falses turn into ones and zeros, or a bunch of integers turns into a bunch of characters after you've run an operation on it. And so because you never told it to do this, and sometimes this happens without even our noticing after we've run a function on our data, it's good to be aware that this happens before it trips you up later. All right, so I've made mention of vectors. Let's now define them. So a vector is just a collection of data of uniform type, for example, of all numerics, all characters. It's the simplest, lowest level, most basic data structure in R from which many other structures are created. So in that bottom line, you can see a data frame being created from these two uniform vectors, first the numeric vector and then the character vector. So you can really think of vectors as the building blocks of R. Okay, so we're going to head over to R, and by the end of this scripting lesson, we should be able to define the word vector as it relates to R. We will learn how to use the concatenate function to build separate vectors, one of each atomic data type, and we'll save them to named objects in R. We'll learn how to use the bracket or extraction function to extract different elements of each vector, and we'll discover the data types to which different mixed vectors are coerced when we're trying to put them together in the same vector. So let's switch over to R. All right, this is our vector script. You can download this from the course repo. The link should be in the description, and you can follow along. There's going to be a couple of points with exercises to do on your own. I will let you just pause the video at that point. Okay, so jumping into creating vectors of different atomic types. The first one we're going to create is a vector called v1. It's just going to be, all it's going to consist of is the number 1 itself. So when we go over here to the console, to inspect what we just made, we see it's just a vector of 1. To find out whether our vector that has the number 1 is a numeric or an integer vector, we can use this function type of. So if we put our vector in as what's called the argument to that function type of, then we should get back the data storage type of that vector, and it is a double. And remember, double and numeric mean essentially the same thing. Another way to get more information about a vector or an object that you've created is this function class. It functions a little differently from type of, in ways that I hope will become a little more clear by the end of the script. But for now, just know it's another way to get more information about the attributes of the object that you've created in R. So our class of v1 is numeric. And then the final piece of information that's pretty important with vectors is the length. And the length of v1 is 1 because it contains a single element. So obviously we didn't have to use the concatenate function for a single element. When you have more than one elements, you can use this concatenate function to build a vector. Let's build a numeric vector v2. And if we use type of on v2, we see that it is a double. It's being stored as a double. If we need it to be stored as an integer, or we want explicitly an integer vector, we can use this L after each number. So v2.5, just this intermediate vector here, is of type integer. If you have a bunch of numbers and you don't want to type L after every single one, let's say you already have a stored object of numbers and you just want to convert them to integers, you can use this function as.integer. There are other functions like it, including like as.character, as.numeric, etc. You can look those up in the help documentation if you're curious. Then that will do the same thing as this above here. Okay. So that's numeric vectors, integer vectors. Now let's create a character vector. We're going to call our character vector of fruits v3, and we're going to store 3 character strings into it. If we inspect it over here, we get our fruits back, and let's find out the length. It should be 3. So next on your own, you can do this exercise for how you might convert this integer vector into a character vector. And then our last type of atomic vector is going to be a logical, and logical vectors only take 2 values, true or false. So if we create this, we get those back, and type of v4 should be logical. You can also do abbreviations, and that will work as well, because these are recognized as these as shorthand for true and false. That's not generally best practice though, because if you come across somebody else's code or you're working with somebody else's code, maybe they've saved a different object to the symbol F or to the symbol T. So it's a little bit risky to not spell these things out, and so generally we try to spell them out. Okay, moving on to coercion of data types. So what we were talking about in the slides. What happens if we try to combine all of the vectors, or some of the vectors that we made above of different atomic types, into a single vector? So for example, let's see, we already used v4. Let's make this v5. Well, let's have v5 be a concatenation of vectors v1, v2, and v3. So it coerced those to a character vector. So if we look at v5, everything should be in quotes now. So even though there were numbers, it was recognizing that some of the things that we were trying to bring together included character vectors, and so it coerced everything to a character. This is going to be the most common coercion that happens. Coercion happens according to a hierarchy. I'm not going to go through that hierarchy, just know that it does follow a logic, and the most common conversion that you're going to see is from numeric to character, or from other types to character. And then the length of v5 should now equal the sum of the individual lengths of those vectors, and we see that it is length 8. So we have grown our vector by concatenating it together. So now that we have a character vector v5, what happens if we try to force it into a numeric vector? So I didn't store this to anything, I just ran it in the console, and it did the conversion. It knew that there were numbers in your vector, but since there were also characters in there, it's giving you a warning message saying that we couldn't convert those characters to numeric. So NAs were introduced by coercion. So it just turned those character vectors into NAs. So that's something to be aware of when you're converting character to numeric. Now let's create a vector called v6, and we're going to concatenate a numeric, a logical, and a logical in a character string. So if you have any guesses as to what v6 might be, it is a character. So again, conversion to character is generally what happens. It's just about anything can be stored as a character. So that's the most straightforward conversion or coercion to have happen. But another thing that might trip us up is if we're trying to concatenate an integer with a logical. So let's look at v7. So we just concatenated this vector 1L and true. If we inspect it, we see that that true value has been turned into a 1. And the reason for this is that when we combined a logical value and an integer into the same vector, R converted or coerced that logical value into an integer. And in R, trues are represented as 1s and falses are represented as 0s. So now if we look at the type of that v7 vector, we see that it's an integer because R coerced the logical to match the type of the rest of the vector according to its hierarchy. Okay. So next, let's go through indexing and extraction and subsetting using the bracket function. And we're going to be working with the v3 vector. So just as a reminder, that v3 vector is our fruit vector. It's of length 3. And so let's say we want to get just the first element of that vector. We can use this bracket notation, and I want to point out that bracket is actually a function. You can look it up with the question mark just like any other function. The only difference is that you have to wrap it in these backticks because it's recognized as sort of a special symbol. So, but we use it to pull out the things that we want from different objects. So if we want the first element of v3, we would index it or bracket it with that 1, and we get the first element back, which is apple. If we want the third element, we just index it with a 3, and we get the third element back. If we want the whole vector back, or just know that giving this an empty bracket is asking it for everything. And again, spaces don't matter in R. I don't know if I mentioned that before, actually. So R doesn't care about spaces. So you could do this or this. It's the same thing. It's a little more readable to have a space in the middle. But that asks it for everything in that vector. And if we want to get another way to get back the whole vector would be to ask it for a range that includes the length of the entire vector. So since we know that the length of the vector is 3, we could just ask it for 1 through 3. But another handy thing to do is to ask it for the full length of the vector. Sorry, you're going to hear my dog rustling around here. He's hoping for additional pieces of peanut butter toast, but he will be disappointed. Sorry, buddy. Okay, so length of v3, and we get that. If we want to get everything except a particular element of a vector, you can use this minus or negative sign in front of the index that you don't want. So this is going to give us everything except the second element of v3. So we get just apples and kiwis. You can also index a vector or subset a vector by another vector. Let's see, so here we're creating a vector of positions, so the first and the third position, and we're saying we want everything in v3 except for the things in those positions. So that just leaves us with mangoes. All right, now let's go over adding to or editing our vectors. So that was subsetting. If we want to add things to our vectors, we can still use the same bracket function. First, let's figure out what is in just before we add to it, let's figure out if there's anything in the fifth position, or if there's a fifth element of V3. We know since it's only length 3 that it doesn't have one, but let's find out what R thinks it is. It says that it's an NA, so it's not applicable, it doesn't exist. But it has no problem with you assigning something to that position. So if we run this line of code and we want the fifth element of this vector to be limes, R is pretty happy to do that for you. So now if we look at V3, we see that it did insert limes into that fifth position of this vector, and to get to the fifth, it just filled in the fourth position with an NA. If you want to add more than one element at a time, you can do that with the concatenate function. So here we're adding 3 additional fruit types to our fruit vector. We've got all the same ones that we had before, including that NA, and then we've just added a few more onto the end of it. And now the length of V3 should be equal to all of the individual elements that have made it up, and we can see that we have grown it to 8. And it's not actually growing, it's making copies, but we're going to get into that later. Okay, so we're finally at the point where we have become familiar with vectors, and we want to know how to combine vectors into more complex data structures. So we're going to use some of the things that we've learned in this script to make a few vectors of different atomic types, and we're going to bind them together into a data frame. So in this first line, I'm creating a numeric vector called A. It's 3 different things. In the second line, I'm using those indexing function. I'm using the indexing function to pull out the first through the third elements of V3, and I'm going to save that to a new vector called B. And in this last line, I'm just converting this vector A from numeric to integer, and I'm storing that as a new vector called CC. And the reason that I'm not naming it just C is that C is already a thing in R. It's the concatenate function, and it's best practice just to not save objects as the same name as functions if you can avoid it. Okay, so we'll save this. And now if we want to just look at all of those at once, this is just shorthand to do that. You can separate objects with semicolons, and it will print them one after another. So A, B, C, C. We see that A is the first thing returned, B is the second return, and C is the third thing returned. So that's just what those things look like. And we're going to bring them all together in a data frame with the data.frame function, and we're going to save it as df1. And now if we look at the structure of df1, we see that we've created a data frame. It's got 3 rows and 3 variables, and our vectors have become the columns of the data frame. So the first column, A, is numeric, B is character vector, and CC is that integer. So if we look at df1 itself, we see that our vectors have just gotten flipped into columns and bound together into a data frame. We know the types of the things that make up the data frame. What is the type of the data frame itself? And it's a list. And we'll be talking about lists next week. But I wanted to end with this to illustrate the difference, that subtle difference that I was talking about between type of and class. So the storage type of that data frame is a list, but the class of that data frame object is a data frame. All right, so that's enough for today. Thanks for watching, and I will see you all next week.